One of the most important things that scientists need to work out is how many people, on average, a contagious person could infect. Now, the scientists call this the transmission rate, or sometimes they refer to it as the R0. And the R0 of seasonal flu is around 1.3. Let me show you what that actually means. Every square on this chessboard is going to represent a new round of transmission. If we start off with one infected person, they will go on to infect 1.3 others, which I'm going to represent with 1.3 grains of rice. Now, each of those people are also going to go on to infect 1.3 others. So by the second round of transmission, it's up to 2 people. These numbers, they're going to steadily increase each time until 8 rounds of transmission, when it'll be up to 8 new people contracting the seasonal flu. Now, the transmission rate, the R0 of COVID-19, is approximately 2.5. And that doesn't seem like it makes much of a difference, but even this very small change actually has a dramatic impact. Because the first transmission means that 2.5 people will get infected. The second round, it's 6 people. And by 8 rounds of transmission, it is this many people. That means that if we did nothing, one single infection would spark off a chain of transmission that within 2 months would leave 99,339 people infected with the virus. And based on some estimates, that means that up to 1,000 people in this single chain of transmission would go on to very sadly lose their lives. Now, this is terrifying. However, there is also some better news, because best estimates from research released last week is that with all of the social distancing measures we currently have in place, the transmission rate of the new coronavirus in the UK has plummeted to 0.62. So just by staying at home, we all have it in our power to change the course of this pandemic. But what is it about this virus that makes it so infectious?
This virus is spreading across the globe like wildfire, and it appears to be one of the most contagious in human history. So I'm here because I want to find out exactly how it's passing from person to person so quickly. At the Francis Crick Institute in London, structural biologist Dr. Donald Benton believes the answer may lie in how the coronavirus's unique molecular structure helps it to attack our body's cells.
So viruses infect our cells, first of all, by attaching to the cell surface. And they do this by a protein on the surface of the virus. For instance, I have a picture here of flu viruses. On the surface here, you can see these little rod shapes are influenza hemagglutinin molecules, which are the spike protein of a flu virus.
These spike proteins latch onto our cells and pass on the disease. Research suggests that this new coronavirus could be up to 10 times more efficient at attaching itself than SARS. The team here are part of a global effort to create the first images of spike proteins on the new coronavirus. They think it could hold important clues as to why it passes on the disease so effectively.
So this coronavirus needs to first of all bind to the surface of the cell, and then it needs to enter the cell and release its genetic material. And both of these activities are controlled by this spike protein.
What is it about this spike protein that makes it more effective than other viruses?
So the surface of the protein which attaches to the cell is different. It has a different mechanism of priming the protein so that it can release the genetic material into the cell.
For the coronavirus to infect our cells, the spike protein must first be split open or cut by an enzyme. This activates or primes the virus for infection.
In normal coronaviruses, this cutting happens after the virus is taken up by the cell. But the idea with this new coronavirus is that it's already cut when the virus leaves the cell, so it's already primed and ready to infect when it leaves.
The structure of this coronavirus means its protein spikes are already cut and primed before it comes into contact with a healthy cell, which could make the infection process easier.
So by having that one less step, it's a quicker process for it to be able to replicate.
So it could make it more transmissible.